welcome to Breaking News. There are 5 students from Universiti Teknikal Malaysia Melaka that successful put antenna booster in rural area in Tawau, Sabah. There are 30 students from FKIKK UTEM, Nurul Zuhairah binti Rosniran, Aziani Nur Nadiah binti Tumingan, Anis Najah binti Muhammad Nur, Nurul Ain binti Azlan, and Izzah Zafirah binti Hamdi.
No signal again. It's okay. We can make our own antenna.
Let's figure out what is TV antenna booster and how to make it. TV antenna booster is an amplifier that boosts the signal level of receiver television signal to enable a better picture to be received. The aim is that when signals are low, the amplifier is able to boost the signal to significant level to enable a good picture to be received by the television, so that is able to give a good picture.
A dipole antenna commonly consists of two identical conductive elements, such as metal wires or rod. The conductors have equal length oriented end to end with the feed line connected between them. Its length is determined by the intended wavelength or frequency of operation. The most commonly used is the center-fed half-wave dipole, which is just under a half wavelength long. When a signal enters the dipole antenna, an electron flow will be set up within the antenna. Due to the effect of the voltage, the electrons will be displaced from the right of the dipole and will be accumulated on the left. This means the other end, which has lost electrons, automatically become positively charged. At this instant, the antenna has a positive voltage at one end and a negative voltage at another end. For another half a wavelength to complete a cycle, when the voltage builds in the opposite direction, the electron flow reverses. The polarity at the ends will also be reversed. This changing polarity produces an electric field in phase with it. When the voltage of polarity is as shown, the electric field is in this direction, from positive to negative. For the opposite voltage of polarity, the electric field is reversed. The periodic nature of the generator-driven charges oscillating up and down in the antenna and the electric field produced is observed. At time t equals to 0, there is the maximum separation of charge with negative charges at the top and positive charges at the bottom, producing the maximum magnitude of the electric field in the upward direction. 1/4 of a cycle later, there is no charge separation and the field next to the antenna is 0, while the maximum electric field has moved away at speed of light c. As the process continues, the charge separation reverses and the field reaches its maximum downward value at time t equals t/2. Then it returns to 0 and rises to its maximum upward value at the end of one complete cycle at time t equals T. The outgoing wave have amplitude proportional to the maximum separation of charge. Its wavelength is proportional to the period of oscillation and hence is smaller for short periods of high frequency. Also, electron flow creates a fluctuating magnetic field. By relating the magnetic field to the electron flow, when the electron flow reverses, the magnetic field is at a maximum and the line of force are in the direction. When the flow stops, the line of force collapses. As the flow reverses, the line again reaches maximum and the line of force are now in the opposite direction. The magnetic field thus reverses its direction at each half cycle of the signal. Following Ampere's law, current in antenna produces a magnetic field. A transmitting half-wave dipole showing the voltage and current due to the standing wave on the antenna is shown. As the current varies, the magnetic field varies in magnitude and direction. The strength of magnetic field is proportional to the amplitude of the current standing wave, while the strength of electric field is proportional to the amplitude of the voltage standing wave. Since the standing wave is mainly storing energy, not transporting power, the current is not in phase with the voltage but 90 degrees out of phase. The relationship between electric field and magnetic field is shown. The horizontal lines are the magnetic field component and the vertical lines are the electric field component. The lines are at right angles to each other that are in space quadrature. Vectorially, these lines represent the peaks of the radiating waves. Their direction reverses at the next half cycle. The peaks of these two waves occur simultaneously. The electric field and magnetic field build and collapse 90 degrees out of phase with each other and constitute the antenna's immediate field. This immediate field produces the radiating wave pattern. The changing electric field and associated magnetic field propagates outward at the speed of light, forming an electromagnetic wave.
Laws and equations that are related is Ampere's law. Ampere's law stated that the magnetic field created by an electric current is proportional to the size of that electric current with a constant of proportionality equals to the permeability of free space. The formula shows where magnetic field equals to permeability of free space multiplied with numbers of turn ratio multiplies with current. The number of turn ratio can be reversed to the number of turns of coils around the antenna. It is stated when n increases, the magnetic field increases. This method can increase the magnetic force in antenna. Then, we can use the value to calculate Lorentz force. Lorentz force stated given a charge moving in an electric and magnetic field, the total force on the charge is the superposition of forces due to electric and magnetic field. The formula shows Lorentz force equals to the electric force multiplies with magnetic force. The direction of current flowing in antenna can be done by using right-hand grip rule. The magnetic flux in antenna can be obtained by using the formula where flux equals to the magnetic field multiplies with cos delta. Delta can be reversed to the angle position by the antenna. The value then can be plugged into the Faraday's law. Faraday's law states that the absolute value or magnitude of the circulation of the electric field, E, around a closed loop is equal to the rate of change of the magnetic flux through the area enclosed by the loop. The Faraday's law formula shows Faraday's law equals to the number of loops multiplies magnetic flux and divide with the change in time.
Like most technologies, there are advantages and challenges to using a dipole antenna. For our group assignment, we need to moving it, placing the antenna to find the best reception beforehand and is susceptible to interference. Our homemade indoor antenna is small in size. So in order to overcome the challenges, we try multiple combinations of pole placement before finding the best reception position. Both poles typically rotate and extend, making it a hassle to move one and then the other continuously while seeking maximum reception. This is in order to avoid the signal from being disrupted. Next, the indoor antenna is susceptible to interference. This could be when transmit the signal frequency, the walls and the ceilings of the house do not permit the signal to make allowed to go to the receiver point. To overcome it, place it as high as possible or move the antenna to the window to avoid materials in wall construction that interfere the signal. That's all. Thank you and Assalamualaikum.